Okay, so we're going to look at algebraic fractions. I've called it adding algebraic fractions. It's probably a little oversimplification, I suppose. Really what we're looking at is we're looking at simplifying, I suppose, simplifying algebraic fractions. And that's largely going to be adding, subtracting, really. So the main thing I suppose to note here is that we know when we're adding fractions generally, if we're just adding fractions that have numbers in them, okay, obviously we're at a point now, we're probably just putting it into our calculator, but we know the underlying concept of what's happening there. We're finding a common denominator. The two fractions then are being added together once they have that common denominator, and we're using that, I suppose, to simplify them into one fraction. So we're going to be really applying that same concept, that same idea to fractions that include x's, that include variables, that include unknowns. And I suppose that's why we're kind of stressing that understanding of what's underlying the methods there, and not just kind of knowing the method off without really kind of knowing why that's the case or what exactly is happening. So as I've said, like adding or subtracting fractions, we find a lowest common denominator, which is generally the lowest common multiple of the denominators, and then we can use that then to rewrite our fractions. So the steps we're going to follow here are to find that lowest common multiple, or find that common denominator, rewrite the fractions then using that common denominator. Generally that's going to mean that we're multiplying the denominator by some number to get it to that common denominator, and then we will multiply the top, the numerator of the fraction, by that same number, okay? Then we will write as a single fraction, and then we will simplify the numerator if we can. Okay, what's important to note here as well is that because we're saying or talking about adding and subtracting fractions, we're primarily talking here about expressions. They're not equal to anything, they're not equations. So methods we're going to look at later, which might involve, multiplying all of the terms or trying to get rid of the fraction, rid of the denominator, those are not methods that are going to apply here. Okay, and I suppose that's quite important. We are obviously still multiplying. As I've said, we multiply to make that common denominator, and we are multiplying twice. We're multiplying the top and the bottom of the fraction. The reason I suppose that is so important is that although we've changed the bottom of the fraction, say for example we've multiplied it by 3, by multiplying the top of the fraction by 3 also, we're kind of, I suppose, creating a situation where the whole fraction has just been kind of tripled. Okay, so you think of an example like a half. If I start with a half and I multiply the bottom by 3 and the top by 3, I get 3 over 6, which we should know or recognize as an equivalent fraction to a half, because that 3 could be divided again into the top and the bottom again. So I suppose it's important to note here that we're never doing something that fundamentally changes the numbers we're working with or the meaning of the expression. Okay, we're only ever doing something in a way that allows us to express it in an equivalent value. Okay, so I suppose to get started, let's just look at an example. We want to simplify the following fraction using the steps that we had highlighted up here. So the first step is to find my lowest common multiple. Okay, if I'm working with 3 and 7, sometimes there may be numbers that are smaller, but the simplest way to start is to maybe multiply the two numbers or three numbers, however many denominators you have, and see what that gives us. So in this case, 3 by 7, that gives us 21. That probably is our lowest common multiple here for these two numbers. I can't, off the top of my head, think of one that is smaller, so we're going to go with 21 as our lowest common denominator here. Okay, so my lowest common denominator is 21. That's quite important for me. That's my first step done. Our second step was to rewrite our fractions with that common denominator. Okay, so let's just kind of pay attention to maybe how we're going to even lay that out as well. What I would like is I would like this denominator on the left hand side to have 21 on the bottom, and that's going to require me to multiply it by 7. 7 by 3, that gives me the 21. From what we've just said at the start of the video as well, I can't multiply the bottom of the fraction without also making the same change on the top of the fraction. And what I have here now is both top and bottom are multiplied by 7, which essentially is keeping the fraction equivalent here. On the other fraction, instead of multiplying by 7 this time, because it starts with the 7 on the bottom, we're going to instead multiply by 3 to again bring it up to that 21. Okay, now there's an important, I suppose, element or step here that I'm going to follow. And what I'm doing is I'm going to, first of all, maybe rewrite this denominator as 21. And we could have done that in the first place. That would have been fine. What I'm not doing yet is I'm not multiplying out the top of my fractions yet. And the reason I'm doing that is to account for this negative sign. I'm going to give myself a little bit of extra breathing space, a little bit of extra working space to make sure that I deal with that negative sign appropriately. And how I do that is I'm going to combine these fractions into one common fraction, following the steps that we laid out at the start, write as a single fraction. So I'm going to write them as a single fraction, keeping that 7 and that 3 on the outside of my brackets, and only now am I going to expand those brackets. So the 7 by 4 will give me 28x minus 7 minus 15x plus 6 there. My eraser doesn't want to work. There we go. Plus 6. And all still over 21. So then 28 minus 15, that's going to give me 13. Minus 7 plus 6, that's going to give me a minus 1. And all over 21. The last little check we could do here is to see whether there's any number at all that would divide into all of the parts of this fraction. And I suppose important to say here that it has to be a number that I could essentially factor out on the top of the fraction. It has to be one that I could work in that way for this to be a possibility here. And looking at the numbers here, I mean 21 has very few factors, 3 and 7 really being the primary ones, and then your 1 and 21, 13 is a prime number, so it's not looking too good for us here. So we're going to basically stop at this point. Now, important to note here as well, with a question like this, we're generally expecting that we're going to end up with a fraction still. Okay, unless we have really common numbers that would end up kind of dividing in and reducing that down to just a whole number and no longer a fraction, you're usually going to end up with one fraction here in a question where we're asked to simplify. Okay, but following my 4 steps there, find my common denominator, rewrite the fractions with that common denominator, combine them into a single fraction, then start simplifying the numerator if we can. Okay, let's have another look now. So this, I suppose, is the other type of question that we could be asked, where instead of numbers in the denominator, we now have variables in the denominator, so we can see those x's there. So in terms of solving a question like this, what we're really looking at, I suppose, is, again, finding that common denominator. And in the last example, we said that potentially there'd be a smaller denominator than multiplying the two of them. When we're working with variables, when we're working with x's, we're not going to know any possible smaller denominator. So the best thing we can do to find my lowest common denominator is simply to multiply the expressions. And you may get lucky here, and you could get lucky that one of the denominators happens to be a multiple of the other. You may be able to work in that way, but for the large part, this is going to be the straightforward way to work with them, and this will always work. Even if there are simpler ways or simpler denominators you could use, this will always work for you. So we've found our lowest common denominator. Our next step now is going to be to take the expressions that we started with and so take the expressions that we started with, the 3x plus 5 here as well, and we're going to multiply on the bottom by our new terms or binomials that we want to add here. I shouldn't say add, I suppose, that we want to include, that we want to have on the bottom there. 2x plus 1 and my 3 here. Okay, so I've just kind of wanted that common denominator that we identified at the start there, and I have kind of indicated how I'm going to do that by multiplying both top and bottom by each of the missing terms. My next step is to combine these into one fraction with that common denominator. As before, I'm not making any attempts to multiply out the numerators of these fractions yet. I'm going to do that once I have them all combined. I am making a slight change here, and I'm just moving the numbers to the fronts of the brackets. That makes absolutely no difference. Okay, what's happening here is just multiplication, and we should hopefully realize or recognize that when I'm multiplying two things, the order does not make any difference. Okay, so on the top of the fraction here, for example, I'm doing 3 multiplied by 2x plus 1. It does not matter which of those two I write first, and I suppose we're more used to seeing the number in front here. Next thing then is to simply reduce the numerator if we can. So expand these brackets first. And finally, we're left with our simplest form there for our fraction. Okay, fairly straightforward, just following those same steps that we have all along and combining our fractions in that way. Okay, let's get into maybe a question or two here. We're not going to do a whole lot of the questions because obviously I want to leave some that you'll be able to do for yourself, but we're just going to kind of flick through and see ones that look like they could present kind of good opportunities for us here. So let's have a look at, first of all, maybe one that has numbers in the denominator. So I'm maybe going to look at this 2013 question here, 5 minus x over 5 plus x minus 4 over 4. Okay, so first of all, first step as always is to find my lowest common denominator. Here we are probably looking at 20, which does happen to be the multiple of the two numbers here. A lot of the time that's just going to be the case. So I suppose if we were trying to kind of simplify our steps here a little bit, our goal is to have 20 as my denominator. Let me maybe write it in orange to indicate what's happening there. But in order to do that, I have to also multiply by 4 on the top. Okay, so I'm kind of skipping a little step there a little bit, just trying to show maybe how we would attempt to speed ourselves up here. In the same way on the other side, I'm multiplying the top of the fraction by 5 and leaving the rest the same. Next step, as always, is to combine my two fractions. I'm not dealing with the numerator yet. I'm going to do that once I have the denominator fully sorted. Next step now is to bring this all together, minus 20. And that's just going to give me x over 20. Sorry, I forgot my denominator here. Over 20, and that's going to give me an overall answer, just x over 20. Okay, we'll have a look at one more example as well of one with variables in the denominator. I'm trying to see, is there one that we can do in any sort of quicker method, but there doesn't seem to be. So we'll just pick one that looks interesting. Let's go with, well, let's go with any of them. Let's go with this one here, the 2010 one. Okay, same idea again. To find my lowest common denominator, I'm going to take my two expressions and I'm going to multiply them. I'm not actually multiplying it out. I'm just going to indicate that that's what we would do. Okay, that the product is probably going to be the lowest common denominator. Okay, as before, we're going to start with the fraction that we have. We're going to introduce that new term, which allows us to have that common denominator. Same thing with my other fraction. The x plus 4 was there originally. The x plus 1 is the term that was not. And I'm multiplying that on the top and the bottom. Okay, maintaining that idea that essentially, if I were to divide those back out, that I would be left with what I started with. Next step, as always, combine them into one fraction with that common denominator. Then look at expanding my brackets. And then simplify the numerator. And we end up with our overall answer here. Okay, so hopefully we're seeing that the key thing here is just to be fluent with those 4 steps. Find your lowest common denominator, rewrite your fractions with that denominator, combine them into a single fraction, and then simplify the numerator, paying attention to any signs there. That's going to be the main steps that we're going to be following, and all of this applying to these expressions, these questions where we're asked to simplify the fraction to write as one fraction, the questions where there's no equal sign. We're going to look then at the equations, I suppose, in the next video and see how there's slight different methods that we can choose to make for those.